in this lesson we're going to look at nuclear equations. And to do that we're going to look at 4 different types of equations that you might come up with, starting off with an equation involving alpha emission. And so we'll start with, for example, radon 222, remembering that the number at the top is called the mass number or the nucleon number. All right, emphasize this. So in some syllabuses it may be known as the mass number. This is really just a resume of what we've been through in the last few lessons. Okay, so that may be known as the mass number. A lot of teachers aren't really happy with this term because it's a bit confusing, because it's not really a mass, it is just a number. So the modern term for this is called the Nucleon number, and it refers to the number of nucleons that are present in the nucleus. Now, a nucleon can be a proton or a neutron. Both of those are nucleons. So that tells us how many protons and neutrons there are, and then at the bottom we have the atomic number, and that's the position the element appears on the periodic table, and this is given the symbol Z, and this one up here, the mass number and nucleon number, is given the symbol A. So radon 222 is an unstable isotope. It results in an alpha emission, and we remember that an alpha particle is a helium nucleus, so we can write the alpha particle as helium 4 2. Okay, those symbols again are the atomic number 2. Helium is the second element in the periodic table, and the nucleon number is 4. The atomic number is also just emphasizing the number of protons that are present in the nucleus. So, and therefore it is the charge on the nucleus. Okay, so that means that radon has 86 protons in its nucleus, therefore its nucleus has a charge of plus 86, and helium has 2 protons, which means it has a charge of plus 2. This is all about nuclear equations, so what we need to say here is that when we write out our nuclear equations, the numbers must be balanced. So we're getting a new element here as a result of this alpha emission. What is that element? Well, first of all, the nucleon number is going to reduce by 4 because the alpha particle has a nucleon number of 4. So we're going to write 218 here. That's going to be the new nucleon number of this element. And to identify that element, we need to look at what happens to the atomic number. This time it's going to go down by 2, so we're going to get 84. We look on the periodic table and find out that what we've got is polonium. All right, so polonium 218 plus your alpha particle. And what is important here, and this is the thing we need to emphasize with all these nuclear equations, is that these numbers must add up. The atomic number of radon in this case must be equal to the atomic number of polonium plus the atomic number of helium. 84 plus 2 equals 86. Exactly the same with the nucleon number. 218 plus 4 is equal to 222. So it's very usual in exam questions that they'll give you an equation like this, but they'll miss out a number. Okay, for example, they say what is the mass number or nucleon number that goes here with polonium. Okay, so that's very typical. Next we'll look at an example of a beta emission, and we'll take, for example, cesium 137, another radioactive isotope, this time of cesium, and the atomic number of cesium is 53. What's going to happen here? Well, we're getting a beta emission, so we remember the beta particle is an electron. Okay, and that has a nucleon number of 0, and it has an atomic number of -1 because it has a charge of -1. Now, there are actually 2 types of beta emission. There is the emission of the electron and also the emission of something called a positron, which doesn't really come into this course. That's more advanced A-level. But at GCSE, IGCSE, we're just concerned with this type of beta emission, which is the emission of an electron That's the nature of this, is it's an electron. So sometimes you're asked, what is the nature of these particles? All right, what is the nature of an alpha particle? Well, it's a helium nucleus. What is the nature of a beta particle? Well, it's an electron. Okay, and as a result of that, you can see, how does this equation work out now? Well, the mass number, the nucleon number, hasn't changed because the electron has a nucleon number of 0. So we write 137 here. We're still with 137, but the atomic number has changed because we've got -1 here. So that means in order for our sums to work out, the atomic number of this element must be 54. All right, so 54 minus 1 is 53. 137 plus 0 is 137. That's all balanced. What is our mystery element? Well, we look up one place in the periodic table. That's to say, we go to the periodic table, find the cesium, that's 53, and look at the next element, and we find that the next element is barium. Okay, so cesium is a group 1 element, barium is a group 2 element. All right, that's all balanced. Next of all, the third type of radioactive emission that can occur is the gamma emission. Now, gamma emission, its nature is not really a particle in the same sense as an alpha particle or electron. It is a type of electromagnetic radiation. So straight away we can put over here, we've got our gamma particle that's being emitted. It's therefore got a 0 mass number or nucleon number, and it's got a 0 atomic number. It's not got a charge on it. Okay, so clearly this means that any type of radioactive emission which involves only a gamma particle, well, the element will not change. It cannot change because there is no change in the atomic number. So our example here is technetium, which is used in medical physics. This is a classic example, and we write out the nucleon number and mass number as 99m, and then the atomic number is 43. Now, the important point here is that this 99m, so what that m means is this is an isomer. So nuclear isomers are nuclei with the same number of protons and the same number of neutrons. That's to say, they're the same element, but the arrangement of those nucleons, of the neutrons and the protons, are different in each. And that results in one isomer having a higher energy state or level than the other. So it's kind of not happy. It's slightly more unstable than the other isomer, and as a result of it, it wants to go to the lower energy state. To do that, it will emit a gamma ray, and it will therefore achieve the more stable state. So we write what we're getting here is still technetium. Okay, the atomic number hasn't changed, but its mass number or nucleon number is now written as 99. So we've gone from this isomer to this more stable isomer. Okay, again, everything's balanced. You've got 99, 99, 0, 43, 43 plus 0. Okay, don't forget that little m there though. Okay, now then, the final type of nuclear equation that we might come across is one where there's both gamma and alpha emissions. For example, uranium-238. I'm talking about in your GCSE courses. Okay, there are other types of emissions, but these are beyond this course. Okay, so let's take uranium-238. That has an atomic number of 92. Okay, and so we're going to get an alpha emission, which is again the helium nucleus for 2, plus a gamma emission, which is 0, 0. So again, we've got to make sure all of these numbers add up. So we're going to take from 238, we're going to subtract 4. That's going to give us 234. And from 92, we're going to subtract 2, which is going to give us 90. So this number, this atomic number, identifies the new element, not the top one, the bottom one. We look at that. Clearly what's happened is we've gone down 2 steps in the periodic table. And we're going to find that we've got in that case thorium. That's 2 elements lower down in the periodic table. This is thorium-234. We check our equation to make sure everything adds up. 92 is equal to 90 plus 2 plus 0. 238 is equal to 234 plus 4 plus 0. Everything's fine.